All right. Hello, DC Summit. Welcome to Con 202. If you are interested in hearing about monitoring and observability for modern applications, you're in the right space. My name's Aaron Miller. I'm a specialist SA, solutions architect with AWS and the container services team. And my co-presenter today is Raj.
Thank you, Aaron. My name is Raj. I'm a senior specialist SA covering containers and serverless. I work with primarily public sector, work with a lot of three-letter organizations. Super excited to talk about monitoring and observability with Aaron.
All right, thanks, Raj. All right, so today we've broken our presentation into three different parts. The first of which is we're going to talk a little bit about observability, what it is, why it's important, how we can improve observability, and also some best practices. This is going to be applicable to modern applications. So when we say that, we're talking about containerized applications, applications such as those that run on Amazon ECS, Amazon EKS, AWS Fargate, but also serverless applications as well. So this can be AWS Lambda, and there's a whole host of additional solutions like API Gateway, SQS, SNS, DynamoDB. And then once we cover some of the observability best practices, we're going to talk about how to put those into practice with the AWS native observability tools. So this includes CloudWatch. This is our AWS native observability platform. And CloudWatch can help with metrics and logs, but also AWS X-Ray, which is our solution for distributed tracing. And then we have a set of customers that would like to standardize on open source observability solutions. And so we're going to talk about those as well. Things like our new Amazon managed service for Prometheus, Amazon managed Grafana, and also a really interesting project, an open source project called OpenTelemetry, and what we're doing in that space. So just to kick it off, since we're talking about observability, I thought it'd be a really good idea to start with a definition. And so observability is a measure of how well we can understand a system from the work it does. Another way of looking at that is, from the outside looking in, we want to try to obtain the health and measure the health of the system. So what does that look like? For a containerized application, that could be looking at CPU utilization. For a serverless application, it might be execution time for Lambda. And there's a few other examples up here on the slide, such as the number of HTTP requests per second. It could get a little bit more complex, like the number of service requests under 200 milliseconds. And if the definition of observability is the measure of the system, that means systems can both be less observable and more. And so I want to talk about why we want to invest in making our systems more observable. So the first one is pretty obvious, right? Visibility. Good data gives us access and visibility into the system. And that also in turn helps us to resolve issues. Nowhere is that more important than when we need to do it in real time, such as if there is a system down or someone is paged and they need to troubleshoot something right away, having really good observability helps. Now you'll notice this slide goes on the left-hand side for more operational issues. As we move to the right, these items are more business-focused. So if our customers directly interact with our application, then the customer experience is really important as well. And understanding the health and how well our applications are performing. Additionally, if our applications have a direct result on revenue, then system down has a direct impact on the revenue to the system. And also just intermittent issues can cause issues and ultimately reflect in poor usability and potentially lost customers. So we know why observability is important. How do we make our systems more observable? And so we do that through instrumentation. And this is a really, really important concept. And so before I go and start talking about it at a technical level, let's just use a real world example. Say we wanted to use this concept on a car, right? And we would know that if we observe a car driving down the highway, we can see it's moving pretty quickly. But from the outside looking in, we have limited data. right? Maybe we have a radar gun and we can try to measure its speed as close as possible. But instrumentation in this example would be what we see behind the dash. So we can see directly the speedometer, but more importantly, we can see how the system's running. How fast is the engine running, right, with RPM? What's the oil temperature? And that's the same sort of concept we want to be able to bring to our applications. So what does that mean, right? Because we talked about observability in the previous slides. We might be able to understand that an application is responding in 200 milliseconds. Well, what if, in addition to that application, it was making a call to a backend database? So what instrumentation can do and say, you know what, 3/4 of that time is actually spent waiting for the database. And that gives us much more visibility. So with the move to cloud native, the data can do, or good data and good observability can give us more than just improved debugging. So as we're designing our systems, the more information we have about these systems, the more real-life data we understand how they're going to operate, what type of information or requests they're going to receive, help us to actually design new systems going forward. It can also help us in the testing process. So if we have really good observability during tests, we can understand how the system operates during load testing, performance testing, interoperability testing. And we can try to and work towards catching issues more proactively. And then ultimately the goal, right, of cloud native is to improve feature velocity. And if good data can help us get there, because one, we have a track record and we understand how systems work, and it gives us confidence to move quicker because we also know that we can measure and understand the system once it gets released. There's another important area where this can help, and that is with the cultural shift as we move to cloud native. So I'm sure you've all here heard of the concept of DevOps. And at some point, it gets really difficult to increase the velocity of innovation and releases if you don't bring developers and operations closer together. And so good data and good observability can help with that process because it can help build transparency across these teams. And if we can break down these silos, we can start having a shared understanding. One really important tenet, right, of DevOps is this blameless culture so that we can make sure that we have retrospectives and understanding when something does fail, that when we look at that, these are complex systems, right? It's not one person or one component is responsible. And I think one of the other good important points is the decisions, right, between these teams get to be driven by real data and not gut feelings. So we understand the value of observability, how instrumentation can help us get good data, and especially with the complexity of cloud systems, cloud native systems, and microservice architectures. Now, how do we make these systems more observable? I'm going to start by talking about 3 best practices of how to approach this. So the first, to be observable, systems should admit events, and these are metrics, logs, and traces. These are often called the 3 pillars of observability. Metrics help us answer the question, what's the application response time? Or is my system operating slower today than it was yesterday? Logs help us troubleshoot, debug components, right? What if a system fails and isn't starting? Or we're seeing intermittent errors. And then traces help us understand interconnectivity. Right? By nature, microservice applications and architectures have multiple components and dependencies. So these are commonly known as the 3 pillars of observability. The important takeaway here is we need to make sure that we don't over-rely on one versus the other. And so in your environment, even by application, you need to find the right balance between metrics, logs, and traces. Okay, so let's move on to best practice number 2, and that is all components should be instrumented. This is not easy to do, right? It's a lot easier with brand new applications, especially if you're using some of the latest application architectures or SDKs, right, the software development libraries. But the nature of microservice architectures are that they're interconnected and interdependent. And so if you have a black box anywhere in your system, it makes it really hard to solve problems, not the ones that like system down, but the really troubleshoot ones, the ones that are really complex, especially intermittent problems, ones that show up and then go away. If you don't have instrumentation across your environment, it gets really hard to find and solve those. Okay, so this is hard. How do we make this easier? Right, and that goes into best practice number 3. Instrumentation shouldn't be opt-in, shouldn't be manual, or it shouldn't be hard to do. And so what we're going to talk about in the second part of this presentation is some of the tools and services that AWS has to help us get this level of instrumentation and insight. But then also, there is a new open source project, I should say relatively new, OpenTelemetry, which we'll discuss in more detail, and how that can help us enhance our instrumentation. In fact, there's a really unique innovation in there called auto instrumentation. And so without actually adding code, just by adding this library to your system, you're able to automatically instrument some applications. All right, so at this point, we've really just talked about instrumenting and collecting data, but there's a lot more to that in terms of actually making this valuable. So what we want to do is we want to go through kind of this circle that we have here. We want to collect this data, we want to turn it into information, we want to extract knowledge so we can gain insight that'll ultimately turn into action, whether that's resolving an issue or designing a better system. And so we've talked so far about the part in the middle, like collecting and telemetry data, but this is really about, this whole observability plan is about educating people, also those that have a lot of experience, deep understanding of the system architecture. But what we're going to talk about next is the item there to the right of telemetry, insights, some of the AWS services and solutions that can help us both collect data and gather and gain some of this insight. So AWS has a service for each of the 3 pillars of observability. We've got Amazon CloudWatch for metrics, we've got CloudWatch Logs for logs, and AWS X-Ray for traces. And Amazon CloudWatch, if you haven't been exposed to it, it is our observability platform. It gives a unified view of the operational health and visibility across all of your AWS services. The goal is a single pane of glass that lets you view metrics, logs, and recently even X-ray traces all in the same CloudWatch console. But CloudWatch goes even further. And there's a rich set of features and capabilities built on top of the core CloudWatch metrics, logs, and X-ray traces. And these include solutions such as infrastructure monitoring, application monitoring, and synthetic monitoring. So if you haven't heard of synthetic monitoring, this is a really interesting concept. So here we simulate an end user. If the application is browser-based, then we can simulate an agent that would actually connect like a browser and take a path through your application. And it doesn't have to be in one location. This can be distributed across the globe so you can find out whether you have issues in certain areas, maybe with extra latency. So we're going to dive deep into these solutions discussed in this slide and the previous slide, and how you can use them to increase observability in both containerized and serverless environments. And to talk about AWS X-Ray, I'm going to hand it over to Raj.
Thank you, Aaron. All right, so now let's take a look at some of the tools and how you can use those tools to instrument your serverless and container applications. So AWS X-Ray is a distributed tracing tool. So distributed tracing is like a mouthful fancy word. What does that even mean? So by distributed system, we mean multiple components such as API Gateway, Lambda, SQS, DynamoDB working together to create your end-to-end application. And tracing means you can trace a single request going through the entire distributed stack and seeing the performance of each of the component. Also, when we talk about performance, of course, there is metrics, there is logs. Tracing actually go one level deeper and helps you understand the performance of your code. Is the particular line that you wrote, is that performing as well as you thought? Maybe you are doing a database call. Is the database call taking too long? So AWS X-Ray help you uncover all those. So how does AWS X-Ray help? It analyzes and debugs performance of your distributed applications. And more importantly, you can view latency distribution and pinpoint performance bottlenecks. So I'm going to show you a couple graphs after that will make this point clear. And because of that, you can identify specific impact to the end users of your application. And it works across different AWS and non-AWS services. So a lot of the time in public sector, the application flow might go into on-prem and then come back to the cloud. X-Ray, using X-Ray SDK, you can use that in non-prem service as well. As long as there's a connectivity back to the AWS X-Ray service, it should be able to collect all the trace from all the components that the request is going through and give you a visualized and all the data. And it's ready to use in production with low latency and in real time. So I get this question a lot that, Raj, does X-Ray disrupt the performance of your system? No, X-Ray follows sampling rules, so it follows a certain amount of data in asynchronous mode, it batch it up, and then it sends it to the X-Ray service. So let's take a look at the AWS X-Ray concepts. So this is a very generalized architecture. Let's say a static website for serverless, where the static website is hosted on S3 bucket. And for API calls to get some dynamic data, you are calling API Gateway API. And depending on the method of the API, it's calling different Lambda function. And the Lambda function may be inserting some messages to SQSQ, maybe inserting some data into DynamoDB table, or calling recognition. So the trace is your end-to-end view, starting from the user to the backend. And each AWS service gives you an insight, we call it segments. Now these are out of the box. So let's say if you just did trace and segments by just clicking a button, it will show you for each Lambda invocation, this invocation took maybe 100 milliseconds, this invocation took 2 seconds. But you really want to know what's causing that call to take 2 seconds rather than 100 milliseconds. So to go further down, you can use subsegments where in the code itself, you could say, okay, track this paragraph of the code for me, or track this function in the code for me. So in this case, we are trying to track how long it's taking to insert this Lambda to the messages into SQSQ or insert into DynamoDB table. So those we call our subsegments. So as you could see, it helps you uncover and answer a lot of the questions like, what was the root cause of a series of API faults? Which customers were impacted? How many APIs were involved? How can I tune my critical code paths, etc. So at the end, X-Ray collects all those traces and gives you a service graph. So this graph is useful for 2 reasons. Number one, a lot of the time customers tell me that whoever is joining the project new, sometimes it's difficult to explain the end-to-end view. You could see since the X-Ray is collecting trace starting from the client to the backend, anyone who is checking the application can see the end-to-end view. And second, you would see little green with a red circle. No, those are not just fancy design. That means some requests actually errored out. So if I talk about this particular architecture, let's say the user is hitting some front end that's hosted in ECS, and then you're gathering some data from S3 bucket, and then from some business logic, you are sending the call to the backend, which is another ECS container, and that backend data store ECS container is grabbing some data from database SQL. So after that, it collects all the data, and it shows you how much time the request is spending in each of the service. So for example, you could see front end, the average latency is 19 millisecond, S3 23 millisecond, data store 17, Amazon SQL 6 millisecond. It also shows you the volume of the transaction, such as 66 transactions per minute for the front end, so on and so forth. Now you can dive deeper. So let's say you want to see why this particular data store is taking a little bit longer time than expected. And once you click it, it's going to show you the performance graph. And you could see that it spiked for a few of the responses. And you can zoom on it, and it can even show you logs related to that traces. And you can find out what was the user input, and then debug your application. So X-Ray SDK is available for Java, .NET, .NET Core, Ruby, Python, Go, and Node.js. It adds filters to automatically capture metadata for calls to AWS services using the AWS SDK, as well as non-AWS services over HTTP and HTTPS. So let's talk about AWS X-Ray Agent for Lambda. So I've given the screenshot on the bottom. So with Lambda, it's very simple to enable X-Ray. You just go to the Lambda console or through API and simply enable active tracing. Similarly, for Amazon API Gateway, you can go to the staging console of API and enable extra tracing. So X-Ray is natively integrated into Lambda. So whenever we talk about applications with Lambda, the cold start comes up a lot. And anytime you change your code, you want to know that, hey, did the cold start increased or decreased because of my change of code? So X-Ray, since it's tracing the entire code, can help you detect how much is the actual cold start, how much is the actual code execution, how much it's taking to call a particular database. And using all that, you can pinpoint issues in downstream services called from your Lambda function. And like I mentioned before, it happens with low latency, in real time, and you can see traces in seconds. So now let's talk about how does X-Ray work with Amazon's container service, namely Amazon ECS and Amazon EKS. So anything is with container, generally we follow this common trend where you will have a daemon set running. So daemon set will basically be an agent or a pod running in your node, and it will collect all the data and send it out. So X-Ray is no exception. So for X-Ray, the X-Ray SDK will send all the data from your application pod or microservices to the X-Ray agent running as a daemon set in your node, and then it will buffer all the segments, and then it will upload to the AWS X-Ray queue. And X-Ray group segments that have a common request, we already saw this, the traces end-to-end service graph, and it provides a visual representation of your application. So now we talked about traces, so now switch our gear towards metrics. So traces is inside your application, you are instrumenting your code, you are trying to understand the performance. Metrics, when your Lambda function finishes processing an event, Lambda sends runtime metrics about the invocation to CloudWatch. So you can build graphs and dashboards with these metrics in the CloudWatch console, and you can set alarms to respond to changes in utilization, performance, or error rates. So when we talk about metrics, it's divided into three main categories. The first one is the invocation metrics, the basic one, which is how many times your function is invoked, errors, how many times it was errored, dead letter errors, if your Lambda is called asynchronously and it's trying to insert messages into the dead letter queue, how many times it failed, and throttles, if you're trying to invoke your Lambda more than the concurrency. The second main metrics are performance metrics. It shows the duration of the function as well as the iterator age. So iterator age comes into play when you are processing messages from SQS or Kinesis in a batch in Lambda. It shows performance metrics for those. And finally, concurrency metrics. So concurrent executions show you the traffic pattern how many lambdas, how many traffic is coming and executing the lambda, causing the lambda to run concurrently, as well as provision concurrent executions. So these are the main ones. Beyond that, we have a lot of other metrics for API Gateway, DynamoDB, SQS to help understand your application. So before I give the control back to Aaron, things to remember the high level, right? So traces, you can go deeper in your code, see end-to-end service graphs, see how your application code changes are performing, and metrics shows you overall picture, the performance, how many times it errored. So together, using tracing, metrics, and monitoring and logs, you can uncover and performance tune your applications. All right, with that, I'm going to give it back to Aaron to talk about Container Insights.
Thanks. Okay, so now we're going to pivot to metrics for containerized workloads. And this is done with our CloudWatch solution specifically for it, and it's called Container Insights. It's got broad support for our container solutions, so that includes Amazon ECS, which is our Elastic Container Service, Amazon EKS, which is our Elastic Kubernetes Service, and it supports them running both on EC2 or if you run them using the AWS Fargate runtime. It even has support for customers that are self-managing Kubernetes on EC2 as well. So CloudWatch Container Insights, one of the challenges sometimes of building a monitoring solution is, how do I create the dashboards? What do I monitor? And one of the benefits of this is it's out of the box with a whole set of built-in dashboards to give you performance metrics across the cluster. So it's not just individual application or pod or task or service. It even has node level and cluster level aggregated metrics, right? All built into the CloudWatch console. Additionally, it has support for Prometheus metrics and Prometheus workloads. And for those workloads, there's some out-of-the-box dashboards for things like AppMesh, Java JMX, Nginx, and others. If there isn't an out-of-the-box dashboard, you can build your own, right? CloudWatch has customizable dashboards. So let's go a level deeper and talk about how this works. So what we do here is the CloudWatch agent is installed as a daemon set into your cluster. And what that means is the agent will run on every single node. And this agent will collect metrics and send them off to CloudWatch. It will collect metrics, and then the CloudWatch console will aggregate, summarize, and then correlate some of the metrics and logs together. I think I already mentioned that it collects instance-level metrics. What's really unique about this is how it collects the metrics. So with microservice architectures, there's very high cardinality of the metrics. And so Container Insights built with CloudWatch a way to go about doing this. And it uses something called performance log events. So what it will do is it will collect these metrics and these events in a log file and then actually ingest it through CloudWatch logs. So it allows for each event to have metrics across a wide array, basically all that cardinality, right, across multiple applications, services, and nodes. And then CloudWatch will extract the data out of the logs and automatically import it into Container Insights. And if you have custom data, it will import it into custom metrics. So this is great for observability of just the system, right? But what about what we talked about earlier around instrumentation? How do I get those instrumented metrics into my observability solution? And that's where CloudWatch Container Insights for Prometheus comes in. So what we can do here is this supports Prometheus counter, gauge, and summary metrics. And it has built-in support for certain applications. I think I mentioned it on the previous slide, like AppMesh, Java JMX. This is also supported on both ECS and EKS, both EC2 and Fargate. So what an application would do, Prometheus has an SDK where you can instrument metrics. And then it uses the Prometheus simple data model, where it's an HTTP web server, and the data can be scraped over a period of time to create time series data. So we talked about metrics for both serverless and containers. Let's pivot now and talk about logs. And we're going to start with Amazon ECS. For ECS, it's really simple. Amazon ECS has built-in service or built-in support for logging. So when you create a task or service, if you choose the AWS Logs driver, logs are automatically sent to CloudWatch for long-term storage and analysis. But what if you wanted to send it to a different location? Or maybe you wanted to filter the data. Maybe debug messages don't want to go to long-term storage, or maybe development environments, we don't want to collect everything. And that's where FireLens comes in. So FireLens is a log routing solution built for support around Amazon ECS. This enables containerized applications on ECS to send logs to not only AWS services, additionally to CloudWatch like S3, Kinesis Data Firehose, and Amazon OpenSearch. You can also send it to third parties as well. How does it work? So under the covers, FireLens is essentially a sidecar container that runs alongside every ECS task. That sidecar is running the FluentD or FluentBit log router. And our recommendation is to use the AWS for FluentBit image. That's our distribution of FluentBit. This can be easily configured in the ECS task definition. So there's a lot of configurations you can do there, including filtering. If there is an advanced configuration that you'd like, you can basically get full support to all the FluentBit or FluentD configurations. You just point in your task definition to that custom file, and then you can use the standard configuration. Okay, let's now talk about Amazon EKS. So Amazon EKS is a managed Kubernetes service. And as you may know, the control plane for EKS is run in a managed AWS account. So these are items like the API server, controller manager, and scheduler. These are not run in the customer VPC. It's completely run by AWS. And so when we talk about logs for EKS, we think about it in two parts: the control plane logs and then data plane logs. Because the control plane is run and managed by AWS, this can be turned on in the AWS console or through the API, and logs will automatically be streamed to CloudWatch. There are 5 different control plane log types. So there's one for the API server, controller manager, and scheduler, but there's also one for the audit log. The audit log is really important, and we always recommend you turn that on. That's similar to CloudTrail, right, for AWS services, but it gives you that level of granularity inside Kubernetes. Every single option that is authorized through RBAC is captured in the audit log. And then lastly, there is also the authentication log as well. So what about the data plane? So we want to turn on logs for the EKS data plane. You can run any Kubernetes supported log router. We recommend FluentBit, and if you haven't heard of FluentBit, you may have heard of FluentD. I believe it was the second graduated project as a part of CNCF after Kubernetes. FluentBit is a sub-project of FluentD. And so you can use either one. We have a distribution of FluentBit. But what makes this really nice is that when you use CloudWatch Container Insights, as a part of setting that up, we talked about how it sets up metrics, but it will also configure logs for you, and it will set this up. And it does it in a best practice manner. So it'll collect all the logs in a log group for applications, a separate one for data plane, things like the kubelet and your container runtime, and then another log group for host-based logs. So it makes it really easy to set this up. So I'm going to hand it over to Raj, who's going to talk a little bit about logging with serverless.
Thank you, Aaron. All right, so now at this point, we learned about tracing and metrics. So while metrics give you the important things that you want to monitor, but sometimes you want to go a little bit further. So let's say for Lambda, you want to know how each invocation is impacting your function cost. Or how much is the memory usage of your Lambda, so that based on that, you can change the amount of memory allocated. So CloudWatch Lambda Insight does that for you. So it gets deeper into insights into Lambda function executions using system-level metrics. You can easily enable it on a per function, or you can run it as whole on all your functions. And then you can review KPIs using CloudWatch dashboard, either multifunction overview or focus on a single function. So on the left, on the top, you could see a little bit of screenshot of Lambda Insights. So you can see it shows the function cost based on the invocation, as well as memory usage. And one cool thing is you can actually query on this data to troubleshoot performance issues. So let's say you saw some function is taking longer. With that function name and request ID, you can run the query as shown in the bottom screenshot, and it's going to give you the logs for that particular invocation using which you can troubleshoot and performance tune. So the Lambda Insights that we saw in the previous slide, it uses a Lambda extension for CloudWatch, which is a good segue to talk about Lambda extensions. So why Lambda extension? A lot of the times, customer wants to use their own monitoring and logging solution. Maybe you like Datadog, or maybe you want a Splunk to store your log, and you don't want the logs to go through CloudWatch. So by default, all the Lambda logs and monitoring will go to CloudWatch, and let's say you want to stream the log to Splunk, you have to set up that streaming and send it to Splunk. Using CloudWatch, using Lambda extensions, you can directly stream metrics and logs to third-party vendors, skipping CloudWatch, if you want that to be. So Lambda extension is delivered via Lambda layers. So Lambda function goes through few phases, such as init phase, when it initializes the underlying Lambda container. During that phase, each extension is registered with Lambda to receive events. During the function invocation, extensions run in parallel with the function, and this enables you to capture diagnostic information, send logs, metrics, traces to the location of your choice. So there is Lambda extension already available for a lot of our partners, such as AppDynamics, Datadog, Splunk, New Relic, to name a few. So like I was mentioning, if you want to stream your logs directly to Splunk or somewhere else, skipping CloudWatch, you can use the Lambda Logs API. So basically the extension subscribes to the log stream from the Lambda and then sends it directly to these third-party partners. And you can optionally disable logging to CloudWatch logs via IAM permissions. All right, now I'm going to give it back to Aaron to talk about Amazon Managed Service for Prometheus.
Thanks. Okay, so this is the third part of our presentation. We talked a little bit about observability, why it's important, how to instrument, and then we just covered the AWS native solutions like CloudWatch, X-Ray, and some of the larger extended CloudWatch family. So many of our customers love CloudWatch and use it as their primary solution. It is designed to be, it's a cloud native, and it's designed to be a unified solution. We do have a number of customers, however, that have standardized on open source observability solutions. Most often, these would be like a Prometheus and Grafana. And so in order to support those customers, we've built two managed services around them. The first of which is Amazon Managed Service for Prometheus. And then just so if you're not super familiar with Prometheus, it's really well known for its simple metrics collection methodology, and Prometheus is this open source monitoring and alerting solution optimized for containerized environments. It's become very popular, and many of our customers use it. And so that's why we released Amazon Managed Service for Prometheus. This is a serverless, Prometheus-compatible service for metrics. So what that means, being Prometheus compatible, is it uses the same open source Prometheus data model, so that's PromQL, and all of the metrics. So if you want to query everything that you use with Prometheus, you can use today with the managed service for Prometheus. Because it's fully managed, it's AWS secure, highly available, and it's deployed across multiple availability zones. One of the challenges with Prometheus and running it at scale is that if you want to have metrics that are stored for a long time, the Prometheus project itself isn't really focused on that. And so you have to look towards some of the solutions in the open source space, like a Thanos or Cortex, right, to get long-term metrics. It can be very difficult to set that up. And that's why moving towards a managed service can get you more scalability, higher availability, without having to manage that infrastructure and configure it. Similarly, on the other side with Grafana, for those that aren't familiar with Grafana, it's an open source visualization and analytics platform, right? And it's designed to allow you to query, visualize, and provides alerting on your metrics. Often those collected by Prometheus, but it has support for a wide range of data sources, including Elasticsearch, Graphite, InfluxDB, and more. So Grafana provides you with tools to turn the time series database, the data in Prometheus, into insightful graphs and visualizations. We released Amazon Managed Grafana to make it really easy to run this at scale. So it's a fully managed service for open source Grafana. We have native integrations for many of the AWS services, including Amazon Managed Service for Prometheus. We make it really easy to integrate. And then we have enterprise-ready security. So what does that mean? We tie into both AWS single sign-on and also have support for SAML. So this allows you to use a third-party federated provider to provide authentication. We also partnered closely with Grafana Labs. So if you'd like to, you can very easily upgrade the service to Grafana Enterprise and get all the additional features that Grafana Labs provides in the Enterprise edition. So let's go a little bit deeper and walk through an illustration of how we use those two solutions together. The first thing we need to do is, even though we have a managed Prometheus, you still need to have a collector installed in your cluster, right? In this example, it's a EKS and a Kubernetes cluster. You could install Prometheus Server, and that's what many of our customers do, but Prometheus recently released a smaller, slimmed-down version called the Prometheus Agent. And the Prometheus Agent is designed exactly for this, where you just want to collect the data from use service discovery, scrape, collect the data, and then forward it to a third party. And so here, we can forward it to Amazon Managed Service for Prometheus. I haven't really talked about what a workspace is, but here we're sending it to a workspace. So a workspace is really just an isolated location dedicated for all of your metrics. In the AWS console, you can create one or more workspaces. One of the reasons why you might create many is that you may want to have different security controls between different workspaces. So within each workspace, you can offer fine-grained security. If you do not want to push your data over the public internet, we have support for VPC endpoints, which is what's illustrated on the slide. So we can have secure access and have the data never leave the VPC. Data that is stored long-term is stored on S3. So that's what gives us the high availability and high durability of all of your metrics and storage. Data is both encrypted at rest and encrypted in transit. In transit through HTTPS, encrypted at rest using the Amazon Key Managed Service, KMS. So it will be encrypted both ways. We also have fine-grained security control. So you can use AWS IAM to offer access and limit who has access to what metrics and what permissions that they have. And then lastly, I want to cover CloudTrail. So you can turn on CloudTrail and see who has had access and who's making the calls. On the far right of the slide is Amazon Managed Grafana. So there is a concept of a workspace here as well. And a workspace here is very similar. It's an isolated environment dedicated for your dashboards. And you can create one or more workspaces. Amazon Managed Grafana also has support for automating all of the dashboards. So you don't have to go into the GUI and re-click and recreate all of them. If you have Terraform modules that set up this, they will work as well with Amazon Managed Grafana. And then I've hinted about this a few times before, and I really want to dive in here. I'm really excited about the OpenTelemetry project. So if you're not familiar with OpenTelemetry, it's an open source project, and they're working to create a unified standard for the management of telemetry data, such as metrics, logs, and traces. Like Kubernetes, OpenTelemetry is also part of the Cloud Native Computing Foundation. The goal of this project is to create a secure, vendor-neutral specification for instrumentation, what we talked about earlier, so you can send your data to any backend of your choice. So that's a lot of words, right? One real simple way to think about this is you can have one agent that's running to collect logs, metrics, and traces and send it to all of your backends. So you no longer need to install agents for every single one of your observability vendors. And then let's talk about AWS Distro for OpenTelemetry. So you may see this abbreviated on the next few slides as ADOT, as we affectionately call it. And ADOT is a secure, production-ready, AWS-supported distribution of the OpenTelemetry project. So we do a lot of work with ADOT, with OpenTelemetry, and a lot of contributions. And if you deploy ADOT and you have enterprise support, you have a fully supported environment. And I'm going to talk shortly about how this works with our containerized solutions. One other important benefit here is that it gives you the ability to instrument once. So OpenTelemetry has a set of SDKs and libraries that allow you to instrument your applications independent of any vendor. And there's this really interesting concept, I think I talked about it right in the beginning, around auto-instrumentation, and that's part of OpenTelemetry. I believe support today is only in a few libraries, but one of them where it's really strong is the Java libraries. So if you connect this to a Java application, you can automatically get instrumentation throughout the application. It's really, really powerful, and this helps us get to our item number 2. We talked about how do we instrument all the applications and all the components. So what I'm going to do now as we wrap up this presentation is, earlier we talked about our containerized solutions, and we talked about how we could use Container Insights and the CloudWatch agent. I'm going to walk through some of those examples and show how you can replace it with the AWS distro for OpenTelemetry, ADOT, and still get the same exact user experience. So the first thing we'll do here in an environment that's containerized, this could be EKS or ECS, is we install what's called the ADOT collector. You can just think of this as a super agent, right? Like one agent that can collect everything. It's vendor agnostic, and it's used to receive, process, and export telemetry data. And I mentioned before, right, the benefit here is you don't have to install all these other agents from different vendors. The collector is also the default location for telemetry data if you end up instrumenting using any of the OpenTelemetry APIs. So once we install the collector, let me walk you through the components and how they work. There is a concept of a pipeline that's configured in YAML, and you can have one or more pipelines, and each pipeline will have a receiver, a processor, and an exporter. And the receiver is how data is ingested into OpenTelemetry. And so you're going to have multiple receivers depending on what you're collecting. If you're scraping Prometheus metrics, you'll have the Prometheus receiver. The second component in a pipeline is a processor. Now, processors are optional. However, they are highly recommended, if nothing else, than just using the batching function. So processors will batch data to essentially keep from hitting API calls or essentially extra calls to your backend exporter. Processors can also perform another important function, that is filtering. So it may be that you don't want all the data collected to go to every backend. And so you can actually have multiple pipelines where you can send maybe development data to one location and production data to another, right? The last item in a pipeline is an exporter, and that's how we get data to the back end. And so depending upon where you're sending it, you'll have a different exporter. If you're sending it to X-Ray, for example, there'll be the X-Ray exporter. Sending it to Prometheus, the Prometheus exporter, and we even have an Amazon managed service for Prometheus exporter as well. So before we showed you how CloudWatch Container Insights worked using the CloudWatch agent, and should you want to swap that out for OpenTelemetry, this diagram shows how it would work. So within the OTel collector, you would define a pipeline that would have an AWS Container Insights receiver. And so this receiver is smart enough, right, and was designed to replicate everything the CloudWatch agent collects. And then we would use the CloudWatch EMF exporter, so we talked about how Container Insights uses performance log events, right, using this structured JSON format called embedded metric format. And so we have a special exporter just for that. If we wanted to do it with Prometheus metrics, so Container Insights for Prometheus, same thing, right? Just a small change. We would still use the EMF exporter, but we would just swap in the Prometheus receiver because now we're scraping Prometheus metrics. And then if we wanted to collect and send data to, and we have an abbreviation here, Amazon Managed Prometheus, AMP, then we would have the exporter for the Amazon Managed Prometheus. It's a special remote write exporter, right? That's a feature of Prometheus, and that's how we send data off to the Managed Prometheus. Okay, so in summary, we've covered a few things here. We talked about observability and why it's important, and then we talked about a number of different AWS solutions, and that includes the CloudWatch family, the extended family, such as solutions like Container Insights and Lambda Insights, and also AWS X-Ray, right, that does our distributed tracing. For customers, I wanted to make sure I mentioned on the bottom of the slide, you can use the CloudWatch agent, but at some point in time, should you want to switch it out, we have full support for ADOT, which is our AWS distributed, or which supports OpenTelemetry. And then for customers that want to run open source monitoring solutions like Prometheus or Grafana, we have full support for that as well. So we really have two paths depending upon what you're looking for. Both of them can be powered by OpenTelemetry and the AWS distribution of OpenTelemetry. One of the most common questions that I get is, how can I learn about these new technologies? Especially in this presentation, we covered probably at least a dozen, if not more. And so we have AWS Skill Builder, which is designed to help you learn. There's 500 plus free digital courses. And then, of course, should you choose, we have a number of AWS certifications available as well. And with that, Raj and I would like to thank you for attending, and we do have time for questions. I think there's a microphone. She's bringing a microphone for you.
You go to the speaker feedback.
Thank you. Thank you. Outstanding. Very quickly, I do have a lot of questions, but I'll try to. Okay, so for the last point on OpenTelemetry, is it support Fargate?
Yes.
Okay.
On both ECS and EKS.
Yes. Okay. Service meshes. When you have a lot of applications that are like black boxes, and you never talked about the service mesh or app mesh or anything like that. Why is that? Why did you leave that completely out of your observability best practices?
So I think there's a couple reasons. One is we were already covering so many solutions that just to talk about a service mesh and all the complexity it brings is probably best served in another presentation. And ultimately, that a service, if you're putting a service mesh in just for observability, you may want to look at other solutions, right? Service mesh has a lot of complexity, and there's a lot of benefits, but it may not be the right solution if the only thing you want to do is turn on observability. So it just may not have been a right fit.
Okay, and last question, going back to OpenTelemetry again, you didn't show anything about traces. You showed metrics, and I'm not sure about logs, but so you would have an exporter for X-Ray or for Jaeger, or like what?
Yeah, we have an exporter in ADOT to send your traces to X-Ray. Or like Aaron was saying, you can send it to Jaeger. Like if you have any open source tracing agent, you can configure it to send it to that as well.
Do you know by any chance if OpenTelemetry is available on GovCloud?
So OpenTelemetry is an open source project. The one thing I didn't mention is that metrics and traces are generally available, but logging is still under active development in OpenTelemetry as a project. So that's not recommended for production yet.
Thank you very much.
Hey, hi, thank you. On the AWS X-ray tracing, Lambda tracing, right? Is there a way to mask certain data? Like I work with a lot of PCI data, and like if credit card numbers or any PAN account numbers are coming, we want to mask certain data so that, because right now I'm not able to use in those parts where it's CHD data, cardholder data. Is there a way to mask it?
So by default, trace will just show the performance metrics, but if you click on it, it's going to show the request. So if the sensitive information is in the request, I don't know on top of my head if there is a way to mask it, but I can get back to you. Yeah.
Good to see.
Cool.
All right, thank you all. Really appreciate it. Thanks.
Thank you.